So in this video, I'll discuss limiting reactants. However, before getting into limiting reactants, you want to make sure that you have an understanding of how stoichiometry works. Stoichiometry basically allows you to use the amount of a substance that is present to determine how much could actually form, how much product could form. So we can look at how much of the reactants are present to determine how much product would actually form. So I'll start with a non-scientific example and then do a separate video with a scientific example. So for this video, we'll just look at making a basic cheese sandwich. So let's say I had 8 slices of bread, had 3 slices of cheese. How many sandwiches could I make? We know that for every sandwich, it takes 2 slices of bread and 1 slice of cheese. So I'm just going to call it B2C because I'm putting 2 bread and 1 cheese together to form this product. And so in order to determine how much product could form, we have to look at how much reactant is actually present. We also have to look at the relationship between what is present and what is being formed. So let's focus on the bread initially. So if we look at the bread, we know that with the bread, for every 2 slices of bread, we can form 1 sandwich. So I'm showing the ratio between the bread and the actual sandwich. But instead of showing it as a ratio when you're doing the calculations, you'll use conversion factors. Conversion factors are basically ratios that are shown as a fraction. So I could show it as 2b over 1b 2c, or I could have flipped it and shown it the other way. 1b2c over 2b. So a conversion factor is basically showing you how these two things are equivalent or how they're related to one another. So in other words, for every 2 slices of bread, I can form 1 sandwich. Or for every 1 sandwich, I'll need 2 slices of bread. We can do the same thing with the cheese. But with the cheese, only 1 slice of cheese is needed in order to form every 1 sandwich. So that ratio would be 1 to 1. If we were showing those relationships as conversion factors, it would be 1c over 1b2c, or the opposite, 1b2c over 1c. So that shows how they're related to one another, but then you'll have to use stoichiometry to determine, based on the amount of each that you started with, how many sandwiches could actually form. So again, let's look at each component. So if we start with the bread, and when doing stoichiometry, you always want to start with the number or the measurement that was provided. So looking at the bread, you started with 8 slices of bread. You then use your conversion factors in order to go from start to finish. So if I'm trying to figure out, using those 8 slices of bread, how many sandwiches I could form, I need to start with bread but end up with sandwiches. So I have to use a conversion factor that relates the bread to the sandwiches and shows me how they relate to one another. So you would start with your bread, and I tend to use what's called a T-chart, which is basically the same as using parentheses with fractions. They mean the same thing. And so once you have that set up, it's basically showing you how to multiply and divide in order to determine the amount of product that would form. So since I'm starting with bread and I need to end up with sandwiches, I need for my bread to cancel. So I need my B in the bottom and my B2C up top. What I typically recommend is that when you're doing stoichiometry, focus on your units first so that you can make sure that you're getting the units to cancel so that you're left with what you needed or what you need. And so I need my B to cancel, but I need to be left with B2C. So I'm putting those units in first. Then I can go back to my conversion factors and look at what number goes with what. The numbers still stay with that item. So in this case, I have B and I have B2C. Looking back at my conversion factor, regardless of which one, the 2 goes with the B, the 1 goes with the B2C. So my 2 is still going to go with the B, the 1 is going to go with the B2C. So by setting up the conversion factor, it allows the unwanted units to cancel so that you're left with the wanted units. From there, you simply carry out your calculation. Everything that's up top, you multiply. Everything that's on the bottom, you multiply. You then take the product of the top divided by the product of the bottom. So I have 8 times 1, which is 8, divided by 2, which gives me 4. So based on those 8 slices of cheese, I can form 4 sandwiches. Let's do the same thing with the cheese. Excuse me, 8 slices of bread, I can form 4 sandwiches. Now we can do the same thing with the cheese. So we started with 3 slices of cheese, but we need to know how many sandwiches could form. So starting with the 3 slices of cheese, so this time just to show what I was referring to, I'll go ahead and use parentheses and conversion factors. Just to show that you'll still get the same thing. I need the cheese to cancel because that's not what I'm looking for. I'm looking to figure out how many slices of bread. This one is a little easier because it's 1-to-1 regardless of which conversion factor. So for every 1 slice of cheese, we can form 1 sandwich. So let's just put the ones in front. From there, I can see that my cheese, so my C has canceled to leave me with BC. Then I can carry out my calculation. So 3 times 1 is 3, divided by 1 is still 3. So based on the fact that we started with 3 slices of cheese, we could form 3 sandwiches. So this is what we started with. The 8 slices of bread, the 3 slices of cheese. Based on the amounts of each that were present, we had enough bread to form 4 sandwiches, but we only had enough cheese to form 3 sandwiches. So in order to determine how many sandwiches will form, we have to identify what's called the limiting reagent or limiting reactant. The limiting reactant or reagent, you'll hear either term used, simply limits how much product could form. It's the reactant that is completely consumed. So you'll use all of it, and as a result, you won't be able to form any more product. So in this case, once we make those 3 sandwiches, we no longer have any cheese to make a 4th sandwich. So the cheese would represent your limiting reagent. It limits how many sandwiches could actually form. After forming those 3 sandwiches, so if we started with 8 slices of bread, 3 slices of cheese, and we started building those sandwiches. After we built a total of 3 sandwiches, that means that we had to use up those 3 slices of cheese, right? So we have no cheese left. We had to use 6 slices of bread. We still have 2 slices of bread left. But because we don't have any cheese, we can't form any more sandwiches. So as a result of running out of cheese, the reaction, or in this case, the sandwich production, can no longer occur. So when you take this same principle and apply it to a scientific example, looking at which reactant you would run out of first, that is the one that is the limiting reactant or the limiting reagent. It limits how many times that reaction can occur. So in other words, because it runs out, the reaction can no longer occur.